development program on the latest trends in image pre-processing techniques, which will include image denoising techniques also. I hope you would have enjoyed the first 3 day sessions done on the impulse image denoising, non-local means image denoising, and non-linear image denoising techniques. So today's session, fourth session, will be handled by Dr. Doreen Robin. She is the founder and director of Computational Intelligence Research Foundation, Chennai. She has been invited as the resource person from various universities and various engineering colleges. She has delivered number of guest lectures, workshops, and webinars, and she has filed so many research papers. Her major research area is in image processing. She's ready to present the research challenges in the digital image processing. So I hope this session should be very, very interactive. Madam's husband, he is also Dr. Robin. He is also an expert in giving the research areas. So they are very famous in giving the research challenges in the real-time applications. So I hope this session would be very, very useful to you. At this juncture, I would like to thank my personal thanks to Dr. Doreen Robin for immediately accepting our invite. Thank you so much, ma'am. I hope our students and the faculty members, the research scholars, would be enjoying this session. I request all the participants to be very, very interactive because we have got an eminent personality. So whatever the clarifications you have, you can interact with madam and get your clarifications done. Later, once it is done, we'll share the recordings. With this, this is over to Dr. Doreen Robin.
Thank you. Yeah, thank you. Thank you so much, ma'am, for your warm welcome. I would like to thank the entire Sona College of Technology, especially the Department of Electronics and Communication Engineering, for having invited me to deliver the talk on research issues in image processing. My special thanks goes to Professor Gayatri, ma'am, for having invited me for this talk. So,
thank you.
We will be starting with the session. So whenever I ask you the questions, I hope my screen is seen. Is my screen seen?
Yes,
yeah.
Yes, ma'am.
Yeah, thank you so much. So whenever I ask a questions, so we are hosting the entire event on the YouTube live on my channel also, right? And whenever I ask questions, you can give your answers on the chat box. The first question for the day: how are you all doing? Let me see in the chat box. How are you all doing today? You can give your responses in the chat box. Like Microsoft Team viewers, yes, doing good. Thank you, Gayatri ma'am. Eldo sir, thank you. Good, doing good, doing good. Okay, you're all doing good. Everybody, I want you to get yourself interacted with the session, right? So it's a virtual platform. We are doing it. So as and when, yeah, fine. Thank you, Sarah ma'am. Yeah, how about you? Yeah, I'm doing fine by the grace of God. Thank you, Vinitha ma'am, from the YouTube, that you say you're all good. Okay, so today's topic we are going to see about image processing. Okay, we are going to see about image processing. Can you specify in your chat buttons, in your day-to-day life, are you using images? If you are using images, can you tell one or two applications that you use image in your day-to-day applications? Let's be quick, please. Do you use images in your day-to-day applications? If so, in what application you use? In your camera, thank you. So how many photos you have taken for the day before? Imagine 1990s, right? We need to hire a photographer to take a photo. Then it takes days to get it cleaned, and we wait to get our photos being seen. All right. Others? Editing photos. Thank you, Jasmine, sir. So, yes, others. Others, you're all very quiet. You don't want to answer? So, college editor. Thank you, Sarah ma'am. The facial image for attendance system. Yeah, some universities, when you go, it recognizes your face. In some, it is biometric, which means your image of your fingerprint. Yes, there your image is used. Very good applications. Yes, for editing photos, right? So lot of applications. Every day we are using images in your mobile. Exactly right. Okay, exactly right. So we are satellite image processing. Yes, thank you, Krishnan sir. So lot of places we use image processing. Okay, how it is. So today's session will be on research issues in image processing. As introduced, I am Dr. Doreen Robin. Okay, in my channel, you can see a lot of talks on machine learning, deep learning, artificial intelligence, digital teaching, right? For a decade, I was teaching engineering colleges. My last work was with Loyola Ecam College of Engineering and Technology as a professor and HOD of IT department, right? So, then we go to the doctor, we go to a surgeon, we believe in him, they do the surgery successfully. All right. And it also happens when you take a student, especially engineering students, at the end of the year, whether if it is a computer science students, are they able to even install an operating system? For it's only 20%, 80% no, but still they'll get 99 CGPA. And if it is electronics, whether they're able to develop something on their own, then I thought we need to start up a research concern where generally our CIRF, the website is www.cirf.co.in. All right, here we work with technologies, we work with research issues, finding solutions to problem, training students, training faculties, training corporates, and also we work with corporate projects. Okay, this is about the main objective of a company. So in today's world, okay, in today's world, we see a lot of data and images. They part a significant part of this day. Okay, for this last week alone, can you tell me how many selfies you have taken? Whether you have taken selfies, if selfies, can you put on the count? I know hoping students are also here in the session. How many number of selfies you have taken only in the last week? Or we will take it in the 72 selfies, Hariharan. Okay. And others could say how many pictures you have taken in the month of August or just a week before. So many times. Others, I want everybody to answer it. Okay, it's very simple questions. It's not any technological questions. Nearly 15 with Jeeta ma'am. Okay, thank you. So others also can answer. Kindly answer the question. How many pictures you have taken? Nearly 20. Mukesh Babu, 20 to 30. See how many pictures. Okay. And it will be usable pictures, non-usable pictures. 50, Akash. 20 plus Kavya. Vinita ma'am, 25. Thank you. So many photos we take every day. We take pictures every day. Okay, so we are working with a lot of images, usable images and non-usable images. Okay, so when you think the images are to be processed, okay, it's a process of analyzing and manipulating digital image. Okay, you're analyzing and manipulating your digital images and provides its quality and extract some information that it could be put into use. Okay, that is the main objective of image processing. It's not what we are doing. We are taking an image, we have it as in mobile, we keep it, or sometimes we put it as a status, or we host it into your Facebook, or it could be in Instagram, or it could be in your Twitter, or whatever it is, right? So that is how we sail through with the images. But image processing is we analyze the image, we manipulate the image, and we need to extract some good informations from the image. Okay, how many of you are using Google Photos? How many of you are using Google Photos? Yes or no? If yes, are you using Google Photos? Google is providing an application. Yes, Hariharan, you said yes, you are using Google Photos. So Google Photos, when you upload, it is asking you some two informations, whether you want a original image or a high quality image. If it is in high quality image, now Google is not restrict on any of your sizes. So whatever pictures you take in your mobile, it will be uploaded onto your Google Photos. After a few set of photos being uploaded, it will classify, taking the features of your photo, and it will classify into the specific names. Okay, into the specific names, so I can cluster it. Okay, so this is called image processing. What we take in a mobile is just a picture what we take in your mobile. And once these images are loaded into my Google Photos, an algorithm runs inside the Google Photos. Okay, an algorithm runs inside the Google Photos, and it tells me, okay, how many people are here and how I'm categorized with people. So this is my Google photo. Okay, this is my Google photo. Can you see here? It is clustering. This is an important research issue that is going on, which is called as image classification or image segmenting. See here, when I click on the people, okay, because sometimes I have lots and lots of images of mine, then it will pick up from my images. Who are mine? So this is me. If I click my photo, all my pictures that are into my Google Photos will be clustered into this. Okay, this is a major application. Okay, this is a major application. Okay, and next, if this is my husband, Doreen Robin, if I click on my husband's photo, wherever in my Google photo he is there, it will be clustered. And consequently, if I take any pictures back, also it will say Renee Robin is in the photo, can I put into the people? I say yes. And this is my daughter. See how I'm not doing, you as researchers, we need to understand there is a lot of classification algorithm that runs behind. And this is my son and my parents, everything. So I just name them up, and whenever any picture is being taken, it automatically categorizes. This is a very big image processing, a research issue that is going on, and still it is upgrowing. It is from 1980s, and still this research issue of image classification, or how do you cluster the images according taking the feature. The main important thing is feature extraction. Okay, nowadays there's a bigger research issue that is going on. I'm going to ask you a question. What is that? What is the product that people use has become predominant after lockdown? What is that? What was before lockdown? What was after lockdown? What is the product that you use before lockdown and after lockdown? When you want to go out, what do you wear first? Yes, exactly, Saral. It is mask. It is mask. Okay. So when I wear a mask, okay, this space, okay, when I wear a mask, this face, this section of my face is getting hidden. And now a lot of researchers are going, and even I've done a little research on it, and still it is, yeah, thank you, Bindu ma'am. Okay, you said you wear a mask. Okay, if I have my entire facial features, it will be like this. When I wear a mask, these features will be hidden. And now there is a face recognition algorithm that is going on with mask and without mask, with mask and without mask. Okay, so when we here, I have my picture of mine with a mask, and also I have a picture of mine without mask. So when I compare these two images, even when I wear a mask, my face recognition algorithm should say me it is Doreen. Able to understand? And that is another research issue that is going on. So how do you detect your face? Okay, how do you detect your face? And moving on to it. Okay, so these are how we process the image and extract features in that image. So as a manipulation of visual data, okay, can you tell me in which application image processing plays a vital role? In which application? When it comes to application, the image processing bridges the gaps, how we see things and how it is, how devices digitally view things. The best example is Google Photos, right? I just take a picture and keep it in my mobile. I sync it with my Google Photos. It processes it and it clusters it. Okay. Can you tell me any of the applications, okay, where image processing plays a vital role? Yeah, Google Lens is exactly. Any other applications that you think where predominantly it is used? Yes? Yes, you can quickly give me the answer. It could be right, it could be wrong, no problem. But I want everybody to give me an answer. Photoshop applications, right? No, how the system sees the image digitally. See, when I take my picture, I just see my picture. That's it, I keep it. But when same picture has been analyzed by Google Photos, it doesn't see it as Doreen. It extracts the features and then maps it into Doreen and then puts it into the people album, providing ads related to people. Yes. lots of application, especially this image processing application has become very predominant when it entered into the field of medical image diagnosis. Okay, medical image diagnosis in medical sciences, right? Lots and lots of application. See, when I go for a disease treatment, I may have like an MRI scan, CT scan, okay, PET or different scans available. If there is one doctor, a doctor can analyze only one image at a time. Say for example, before the doctor sees there are 100 patients waiting, I feed all the MRI scans to the of the patient, and my algorithm will tell what is the disease it detects. Okay, what is the intensity of it? The first level is done, and then the final word they can have with the doctor. So when we process with large scale applications of, especially in medical image processing, there's a huge research problems, okay, that is still going on in medical image processing. All right. And now, and yeah, how I see an MRI scan, I don't know anything, right? Because I'm not a doctor, I'm not a medical doctor. I can just see the scan, okay. But the same thing when it's digitally, when I have an algorithm that understands, extracts the features of MRI and finds what kind of disease and what is the intensity of disease. The entire way that I see the MRI scan, how my image processing algorithm, how it is going to see the MRI scan will be entirely different. That plays your research issues. And then after it is being done, but image processing or any machine can never replace human, and final word can be done with the doctor, but the doctor will have the report that is given by my algorithm. So image processing bridges the gap in how I see the things and how devices digitally view things. Can you understand this, right? How the device, how I am going to write my algorithm into it, and how it is going to visualize it, how it is going to extract the features from it, and how it is going to report it. There plays your image processing plays a vital role. Okay. So you can merge two images. That's what I said an example, with mask and without mask. But still, if I'm going with the mask, my algorithm, when a camera captures my image, it should say it's Doreen and it's permitted to enter into the campus. And if I go with my mask or without my mask, I need to refine my algorithm. Before mask, it's okay. Nobody wears masks, right? But after, now I need to write an algorithm. There's a lot of research issues going on, and people are still working on with that. Okay, what are the different common image processing tasks that we do? We display an image, we crop an image, we do all cropping in your mobiles, we flip your image left to right, we can rotate images. Okay, then I need to segment it. Say for example, I'm going to work on my data set which has a tumor. Okay, it's a brain tumor, or it could be a cervical tumor, or whatever it is. When I feed my image into my algorithm, it needs to find the area where the tumor has been affected, and I have to segment it and find out on what level of disease it is. So image segmentation, I told you the example of classification. The best is the Google Photos. As some students are also here, try to survey yourself. What is the algorithm that Google Photo allows? Okay, what is the algorithm that Google Photo allows? And they keep refining it. It is not the same. Feature extraction, this is the first pre-processing. What is my size of my eye? What is the color of my eye? What is the color of my skin? Okay, so all these features are feature extraction process are done. Image restoration, say for example, if I'm going to load a video of or a photo taken in 1980s, what will be there? If I'm trying to process my image taken in 1980s or my video taken in 1980s, what will be there most? Hello, you're all there? Can you respond, please? What will be there in the image more? You can give your responses in the chat box. Distortion, exactly. I always get responses from Sarah the most, and now it's Joshua. Noises. There are different kinds of noises. And when you work with image processing, we need to pre-process the image before we start working with that image. So we need to remove the noises. How to remove a salt, pepper noise, or whatever different kinds of noises are available. Okay, so that is one of the major issues, right? And image restoration and recognition of images. So Python, why do you use Python? It's an excellent choice for image processing task. Okay, as it grows with its popularity and it's free of cost. So there are many packages available. You need not code everything. I'm going to share with you about the 5 packages. Okay, the 5 packages: scikit-learn, numpy, scipy, pill, or it is called a spiller package, and OpenCV. CV stands for computer vision. Okay, these are the majorly used 5 Python packages for image processing, and inside each packages there are lots and lots of functionalities available, but you need to know how to work on with that. Okay, when I take scikit image, okay, so it's an open source package. It implements algorithm that is used in researches, or you should know how to work with an algorithm. It's very straightforward. Okay, so I'm going to show you how to use image filtering. Okay, I'm going to use, yeah, can you see here what's the first package I said? It is scikit's image. Okay, so this is the package. sk image is the package. I'm importing it. Okay, I'm showing you now. I'm importing matplotlib. That's a package to plot things. Okay, .pyplot, that is plt. I'm making it inline, so I want to see my output here itself. This is the first package. Okay, this is the first package I'm using it. From sk image, I'm importing data and filters. Inside this package itself, there are a couple of data sets available. So to get my data set, I'm using data. I'm going to use a filtering operation. You imagine how many of you seen after you prepare a tea, we filter it because you want to remove the tea powder and the extracts. Like I want to filter things, I'm going to use a filter. Okay, image is equal to, there is a different data sets available. I'm going to use this data set called coins. Image is equal to data.coins. Edges is equal to, okay, I'm making my data, the coins image, into this variable called image, and I'm going to use a filter called Sobel filter. I'm going to show it. Okay, so this is my image after taking edges. Okay, after the edges have been taken, can you see that? After it is filtered. So this is a first example for image filtering. So using scikit image, I have shown you an example of how to filter an image. Okay, so this is the package. sk image is the package. Okay, this is the original image, and after filtering, can you find I'm able to see the edges even more clear and specific. See, this is the original image and this is the filtered image. All right, and next package, first I told scipy, the next package we are going is for the numpy. So numpy is a very core library in Python programming. It's basically used in machine learning algorithm, deep learning algorithm. Python has its hands on all the application. Okay, an image is essentially a standard numpy. When I take an image, it will be in a numpy. It's a dimensional array. And what are the operations you can use using numpy? You can use it for slicing. When I want to slice an image and take and extract it, if I want to do a masking, and if I want to have a fancy indexing, image can be loaded using sky image and displayed using matplotlib. So I'm using numpy, and again I'm using the package what I used in the first. You remember it's right, scikit-learn and matplotlib. And the first time I used a data set called coins. Now I'm going to use a data set called camera. Okay, and I'm going to check with you what is the type of it. What is the type of it? Can you see here? I'm using import numpy as npy, and then I'm importing the data. Okay, and here I'm using data.camera off. Okay, I'm typing what is an image. Okay, what is the type of the image? Okay, maybe I think I need to give a print type of the image. Shift. Okay, so I'm trying to, so it will be giving me an answer as numpy as the star gets come out, and I'm masking the image. I'm here, I'm going to mask the image 87, and then this value, and then I'll be showing you my image. Okay, then I'll be showing you my image. So once it is done, my output will be of this kind. If you zoom it, it will be clear. Yeah, I have zoomed it. Okay, this is my original image and this is my master image. Okay, initially first for my SkyKit image, I used an methodology called filtering mechanism. I use Sobel filtering. For the next packages, NumPy, different applications I can do slicing and different applications, but I'm using the methodology called as masking. Okay, called masking. Okay, and the next package. Is it clear till now? Okay. Next, the third package is SkyPy. Okay. Here, SkyPy is a submodule of an n-dimensional image. It is basically used for filtering. Linear and non-linear filtering functionalities are available in SkyPy. A binary morphology that is available in SkyPy, and B-spline interpolation and object measurements is done in SkyPy. So I'm going to use a blurring operation. You remember in SkyKit we did filtering, and NumPy, using NumPy we did an operation called masking. Okay, and now using SkyPy, okay, I'm going to use a Gaussian filter. Okay, so Gaussian filter where I'm going to blur the effect. You remember, can you tell me in mobile what is the option that you give to focus on one image and blur the backgrounds? Can you give me your answer, please? Yes, be quick. You're all students. You will be using it more. Portrait. Thank you, Lishma Shruti. It's portrait. So when I select a picture with portrait, it identifies, even in camera, whatever the mobile use, a lot of image processing algorithm runs at the back. Okay, so it takes your picture, okay, and blurs all your surroundings. So that blurring effect has got different filters. Here, for example, I've shown you about the Gaussian filter. So I'm from my from my SkyPy. First, you remember in NumPy import a data from my SkyPy. My image data sets are inside this package. So misc.faces, I'm loading it and I'm blurring it. Okay, it's blurred and very blurred. Okay, I can also show it to you. Maybe a lot of applications are running in my mobile, in my system. Is okay. Let it get run. I'll show to you. So this is my original image. This is my blurred image, and this is my very blurred image. So can you see the intensity? So using SkyPy, we saw how to do a filtering. Using NumPy, what is that we used? For masking methodology, for SkyPy, how you can do, there are different applications in SkyPy. And one such application we have taken is a blurring using my Gaussian filter. There is not only Gaussian filter, there are n number of filters available. All right. The next thing that we're going to go is called pill operation. Okay. Pill, Python image library. Okay. It's a free library operation. Okay. It's a free library. Okay. What are the functions I can use using pill? Okay. Opening, manipulating. All right. I can also save as different image. What are the different image formats available? Let me hear from you, both YouTube viewers and your Sona college students, faculties, and the registered participants. You can give me the list of, yeah, thank you, Hariharan. So the entire video has been streamed onto my YouTube channel. Just you put Doreen Robin, you'll get my YouTube channel. Kindly like the video, subscribe the video, and share it to your friends whom you think it will be of good use. So whenever I come online, maybe on September 9th, I'll be coming online using my channel on Python for data sciences. Then it will be whenever I come, and you can utilize whatever the sessions I've given, 3-hour sessions, 1-hour sessions, and it keeps going on. It will be useful. Yeah, thank you. JPEG, TIFF, PNG. What are the other formats available? YouTube viewers, kindly give your responses in the chat box, please. Yes, sure. So these are different images. Using Pill, one image I can upload, I can get it of different types. Okay, and fortunately it's actively, and it supports Python 3. The new version is for Python 3. And what are the image applications, processing applications that I can use using Pillow? Point application, filters with built-in convolution kernels, color space convention. So I'm going to use an image filter. Okay, so from Pill, I'm going to import my function called image and image filter. Using image, I'm going to open an image, and I'm going to show the image, and after that I'm going to enhance the image. That is how much contrast. You do a lot of color corrections. You take can you tell one or two applications, like your college students, right, and faculties? What is the application after you take a normal picture? What is the application that you use to enhance your picture to look even more fairer? Quick, please. Do you use it? How many of you agree you use applications that you can? Thank you. Hariharan is the most active person. Yeah, you use it. Yes, a lot of people. Okay, a lot of people use different, which means each and every mobile application behind that runs an image processing algorithm. You can write your own algorithm using Python, and you can create your own application, host it onto an app store or Play Store, and you can earn your money, right? So it's not only as students you are using or faculties you are using it. You should know what is that runs. Now I'll show you the demo of okay, a Pill. From Pill, I'm importing image filters. Okay, so I'm opening this image, and I'm trying to show the image to you. Okay, it will show me an enhanced image. Just give me a second. I'm leaving this page. It is running. Okay, so I will show you how it works. Okay, how it works. Before that gets loaded, let me move on to my next. This is my original image. Can you see the 30% enhancement? I can make it 30%, 40%, or whatever it is. Okay, I can enhance it. This is the major. So what are the applications we have seen? Packages. NumPy. First is SkyKit. Then we saw about NumPy, SkyPy, Pill, and OpenCV is the major package. And OpenCV is the major package. Okay, that is available. Let me try. It's getting loaded. Let it get it loaded. Okay, and then I'll get an output of it. Now coming to OpenCV, open source computer vision library. Okay, here I'll be using it for it is in the field of deep learning. After artificial intelligence, machine learning, so deep learning comes in. It is working very faster, and it is as a research project that started in Intel. It is the largest computer vision library. Okay, that holds more than 2,500 algorithms and even more than that. Okay, it has a lot of functions to write, display, color spaces, resizing, image rotation, translation, simple image thresholding, edge detection, and face detection. Okay, so let me start with that. So this is a simple application. The package is called import CV2. Okay, CV2 is my OpenCV. I'm importing matplotlib and I'm reading an image. Okay, I'm reading an image, CV2.image of, okay, and I'm converting that image into an RGB using CV2.cbt color image comma into an RGB, and then I'm going to convert it into a grayscale. So my image variable contains my RGB, this contains my grayscale, and I'm showing my original image. This is the original image that I hosted it, and then I'm showing you the grayscale image. Okay, now here I'm going to use a binary threshold image. Okay, I'm going to take the binary value of it, and then can you see this is my binary image. After I get my binary image, I told you in medical applications, finding the contours or the edges of the disease where it is affected plays a vital role. So I'm going to use the function called find contours, the edges, okay? And then what is the function, what are the parameters I need to give? I give it, and now I can draw my contour. So this function is used to find the contour, and this function used to draw my contour. and just showing my image with my contours. So when I want to get my contour, it is not, because if I have a color image, it is not possible. So first step, I need to take my color image. Second step, I need to convert it into my grayscale. Then my grayscale image, I feed it, I convert it to my binary. In my binary, it's only black and white, and it is very, very easy for me to find the contours once it is done, because whenever I want to use this function called find contours, I need to give the image that is of image binary type. Okay, so I give it as binary, so the images will be very clear, and I'm drawing my contours. Okay, so this is about for finding my contours. Even if I want to work with tumor detection, when you see there are different kinds of tumors, with tumors and without tumors. So these are images without tumors, and these are the images with the tumors. And once I run my algorithm, it will clearly find and tell me how many from my data set. There's a video in my YouTube channel, how do you convert my training set and testing set, and how do you evaluate it? How do you evaluate it? So when I'm going to this is one method of finding a contour, and there's a predominant algorithm called as CANI. Okay, there is an algorithm called CANI, C-A-N-N-Y. If I use a CANI algorithm, it finds the gray images and it gets my contours. So there are different algorithms for finding the contours. All right. Is it clear till now, whatever I said? Yes, no, no, yes. Okay, so how to read an image, and also I can get this is my image. Okay, I'm going to take an image from a URL. Okay, I am going to use this package called CV2, which is an OpenCV. Okay, and then I'm reading the image and having it in my variable. Okay, and then I'm finding what is the data type, what is the size, what is the shape. I can also generate the histograms of an image. Okay, histograms of the image can be done. Okay, and can you find the contours there? It was a clear contour. If you see here how the contour is being done. Okay, I can enhance it, the level of brightness, the histogram equalization. Okay, lot and lot of things can be done using OpenCV. Okay, so how you can understand how an image could be NumPy. So it is a 2-word pixel values. All right, and then I can use what kind of colors I want to read. I showed you an example of how I took an image, then I converted into a grayscale and then a binary. Okay, and then we are able to find contours. So this is an example of how to resize. You should have seen the image of the cat. Can you see? It has been a resized image. I'm using the function of resizes. Okay, I can enhance it. Okay, resizing of image is possible. Okay, and I can make it as nearest or linear or area or cubic. These are the internal functionalities. I can rotate the image. We can do a translation of an image. Okay. And thresholding of an image, and for edge detection. Okay, for edge detections, that is to find context. I'll show you one more example. I told you about canny, right? I'm just taking a simple image. I'm just taking a simple image, okay, of a brain which has a tumor. Okay, this is a brain. I'm loading an image with a tumor. Okay, and then I'm converting into my grayscale, and I'm using this function called canny. Canny is an inbuilt algorithm. And can you see here, when I given an image, it is clearly marking out where the tumor has been affected. Okay, where the tumor has been affected. Okay, so there are different methodologies that I can do. Okay, one such method is canny, and in medical imaging, this edge detection plays a vital role. All right, and then for face detection is also possible. Okay, how do you detect a face? There are hair cassettes where we write an example which takes the different features, lines and negatives, and then it finds your eyes. Okay, and this image segmentation, how do you mask it and you take your image segmentation? These are the predominant technologies that has been done. Okay, so I showed you about OpenCV, right? How to read an image, and then how do you convert it to a grayscale? The same example I showed you with the thumbs up image. Thumbs up, this is the resize. I told you, the resizing of image. Resizing the image. I can make it as original, half, whatever it is, according to my application. We can do a rotation. And now I'm shifting it. If I want to shift the image, I can use this shifting of image, and these are the different thresholding. The same image, binary threshold. So for binary threshold, according to your application, we should use whatever threshold. For this example, I've shown you all kinds of thresholds, and this is an example of canny again. Okay, and this is an example of, if you want to detect my frontal faces, okay, only my frontal face, okay, and that it allows. Okay, it takes time to run. I'll just run it once again. So I've loaded an image, and we have to give in the XML form, or if I want to do only the frontal image or whatever it is. Okay, I'll be reading a test image. Okay, and then I'm converting it to grayscale, and I'll be finding out what are the scales available, and for drawing rectangles around the face. Okay, so far we have seen different packages and how it works. Okay, medical image also plays a vital role in finding detection of tumors or whatever it is. There are the best challenges, okay, in your research. Okay, and there are different segmentation. How do I do a segmenting of an image? Okay, this technique here, we have granules. So there are two types of segmentation. One is a semantic segmentation, and it's an instant segmentation. So if you see here, there are 5 people. I just segmented, it takes only the outline. Okay, we'll classify all people as a single instance. That is semantic segmentation. According to application, we should be very clear what kind of segmentation we need to use. If I use an instant segmentation, it will clearly demarcate what are the with a clear disparities. Okay, how it is been, the distance of each image will be taken. Okay, and This is an example of instance. So RCNN, convolution neural networks, is to extract features of maps from the image. I will check it out. Okay. And so, okay, how do you get a CNN? Okay, here these features are mapped. Okay, they go through the first process called region proportional network. If I have an image with 2 cars or 3 cars that is running on the road, I need to find the region proportional network, so which returns the candidate boundary boxes. Okay, which contains my candidate boundary boxes. I'll quit it and again I'll start it running it in Jupyter. I'll restart again. Okay, once it is getting restarted, I'll show you how the frontal faces are being taken. Okay. And before going into that, I'll be telling about about this RCNN. Okay, it is used to extract features maps from the image. Like ROI is the region of interest. Then first step, I have to find what is my region proportional network. I have to return that will return my candidate boundary boxes. Then my region of interest. What is the object I'm needing to take it? A lot of surveillance and cyber forensics also this is used. Okay, then it goes to a fully connected layer to classify. So first it goes to the convolution network, then it goes to the region proportional where you find which region, then the region of interest, then it goes to the fully connected layers and it converts into the classes and the boundary boxes. Okay, how do you extract images? And making it image processing, how to make the image like in CCTV surveillance, both images and videos. Okay, whether there is a murder that has been taken. So it detects the objects. Okay, and using a file segmentation mask, because mask RNN extends to the RCNN. Okay, it adds a branch. Okay, it runs in parallel with your boundary, and here it is very fast. Okay, so this is the first time what I showed you the same step. The backbone model. Okay, it is a backbone model as your convolution network. Using that, it runs, it extracts the features, then it goes to the RPN, which is the region proportional network. Once we find the regions, then it goes to your RYI, and once the region of interest have been taken, it goes to your fully masked. So if I'm going to take my mask RCNN, can you see? This is my entire image. Then each region it takes, and then from which I'll be able to do my segmentation and find what is that is needed of. So I have an image like this. After I go to my image masking, there is a dog in the image, there is a book in this image, and there is a boy in this image. Okay, and which sofa he sits. So this is an output. So once you take a segmentation of the image, then you'll be able to clearly find out. Okay, then you'll be able to clearly find out how it is being done. Okay, and with that, what kind of work you need to do? Okay, according to applications. Okay, if it is for a medical image, or it is for satellite image processing, or geo networks, or whatever it is, according to we will take the extracted image from your RPN, then RYI, then it goes to your FC, and once it is being done, then it will be going into a next phase of processing. Lots of applications these are the recent trend application that it runs. So I'll show you the example using mask RCNN. Okay, I'm using it on, I'm giving an IDs. Okay, I'm using RCNN model using COCO datasets. What are the IDs? So these could be an object, a toilet could be an object, a laptop, a mouse. Every object has been mapped with an identifier. Every object has been mapped with an identifier. Okay, it has been mapped with an identifier. Then what I'm going to do, so after this has been done, I'm loading an image, okay, directly from a web page. Okay, and I'm just displaying it. This is the image. So I want to extract, I want to detect the objects that are there. After seeing this image, can you answer me? What are the images? What are the objects there are in this image? Quick, please. Put on the chat boxes. We are going to complete within the next few minutes. When you see this image, we'll see the difference between human brain and the mass car CNN. Kindly give your response in the chat boxes, please. What are the objects that you can see in this image? Only Ariharan is answering. Others, please. Let me see how many of you are here. Yeah, we have 60 plus people and 100 plus people in YouTube.
Participants, kindly be interactive.
Yes, trees, yeah, houses, cars, vehicles. Thank you, Prabhakar sir. Yes, please. What are the objects you see? Okay. Okay. And now coming into, I'm using my TensorFlow, for which I'm using a TPU, because I cannot use TPU in my Jupyter. I came into the Google Colabs. Okay. And once it is getting connected, I already have my pre-trained COCO model. Okay. Once I done my COCO model, you remember what is segmentation? Semantic segmentation and instance. Semantic means it takes the entire object as one. I don't want that. Here I need an instant segmentation. Here I need an instant segmentation. How many objects, how many detection? First I'm initializing using a list. Okay. Then I'm visualizing. Can you see here? So what is that object that I want to give? I've given that number. Okay. And here it is detecting only the people. Can you see here, detecting people? It is detecting car. All right. So, and each one of them will have a key. Each one of them will have a key. Likewise, I need to decide upon what I need to retrieve. Okay, what object I need to retrieve from the image that has been given, using the IDs, using the COCO models are all already been done. Okay, so this is an example for your image object detection. Okay, object detection in the image. Okay, object detection in the image. So this is all done using OpenCV. Okay, it is all done using OpenCV. And yeah, thank you, Dinakar Sarkar. Lot of people, buildings. Thank you, Bindu ma'am. Thank you, Devi ma'am. So this is about, I showed you an example. What are the research issues? Okay, what are the research issues that is available in the image processing? The reason, a lot of papers are being published. Even recently, 2019 and 2020, a lot of papers are being published. Only the open and research issues. Okay, I showed you this. Maybe I'll run this again. I'm importing my CV. Here I need to have my, this is an existing hard cassette frontal face. Okay, it detects the face. Sorry, oops, I'll run this. So I'm using my frontal, I'm using a test image. So this is my test 3 image. This I have uploaded. Okay, this test 3 image, I'll just check it out. I've uploaded here, test 3. Can you see? This is my test 3 image. So this is my father, my mother, my husband, myself, my kids. So I want the frontal face to be detected. Okay, so here in this application, I'm using my frontal face alone. There are different XML available. I'm using the hard cascade frontal image. I'm giving my image, the test 3 image that I showed you now, the test 3 image. And I'm using my CBT color. There are different, right, like gray color using OpenCV. And I'm detecting multi-scales and I'm drawing the faces around. Can you see here it is detecting my face, my husband's face, my children's face, my mother, but not my father. The reason behind the color of his shirt and the background C merges, it is not able. So this is a research problem. I need need to write an algorithm and refine it and make a concentration more and find the boundary and then need to detect the frontal phase. Likewise, lot of research problems are available. Okay, in biomedical imaging, in computer visions, in segmentation, I showed you how do you segment it. So first I showed you in MRI, using an MRI, how can you take your contours. In computer vision, I showed an example how to detect objects. This I showed what is available. And when you go deeper and deeper and deeper, lot of issues are there in finding contours and video analysis. Like there is the current plethora of image technology like MRI, CT, PET, OCT, ultrasound, lot of images. Just when I scan it and send it to my machine where my algorithm runs, it will be able to detect what kind of diseases and what is the list of diseases. There is a huge open research issues that is going on biomedical engineering. The next becomes the computer vision. In computer vision, the technology teaching a computer, like how do you do an image and video. I showed you a lot of example using CV2. How do you recognize the patterns, the way in which one speaks. Then image will be taken and then automatic translation. Okay, then it is taken by that. And biological vision, artificial, augmented reality. Can you tell me any of the examples of augmented reality? I was taking a class for virtual labs, right? Virtual labs, a lot of augmented reality, the AR and the VR application. If you know any of your examples of AR or VR, just post it on your chat boxes. For mathematical modeling, for statistics, for probability optimization, computer vision plays a vital role. Segmenting and classifying, breaking the image. I showed you an example, right? A dog, a boy with a book on a sofa, how it is doing then segmentation. There are three types. One is semantic and instance. More predominantly instance segmentation is used. Okay, and video analysis, you should have seen a lot of CCTV when you see in your Facebook when a murder has been taken or somebody is இப்போ கூட நீங்க பார்த்திருப்பீங்க a lot of videos, right, of a murder, even that Thuthukudi, lot of the CCTV videos were keeping going on. Once an image is there, once it is fed into an algorithm, it will be able to categorize and interpret more digitally how it could be interpreted by a human. Okay, the current trends in image are multi-image fusion. So surveillance using infrared and vision cameras. Okay, how do you superimpose or fusion of both CT image and MRI image? If you fuse both, I could be able to detect the disease even more better and accuracy with an intensity. And in hyperspectral image, like food fraud detection, if I take an image of a food, I'll be able to take what is the fraud of it, fraud done. Okay, object identification, I showed you an image, right, of object, and then how I'm able to identify the people and the cars according to the IDs whatever I give. Okay, the earth surface. Okay, visibility of seeds in agriculture. Now recently a lot of agriculture, when I see a seed, how it monitoring of environmental conditions, target recognition and tracking. Okay, in the vehicle systems. Okay, in GPS it has been done, in forensics. Okay, and in medical sciences also. Okay, to show you a lot of difference on medical sciences and treatment, what kind of treatment could be done, what kind of planning, monitoring, disaster management, the landslides. Okay, the landslides. And underwater, when you go for underwater, you see a lot of fishes and images that could be done, you both using 2D and 3D images. Okay, so in the session I showed you, we started with what is image processing, how it is different, and we have seen about the different packages. We have seen the packages of SkyKit, the NumPy, the SkyPy, the Pill, and then OpenCV. In OpenCV in detail, we saw about what are the different manipulations that could be done with object detections on an image, only the frontal image, right? And how do you segment it? We saw in depth about mask RCN, how it can be used to figure out detect the objects that is an image and the major research issues. Okay, and this is my address. Okay, my email ID doreencirf@gmail.com and my mobile number. Any questions, please?
Good evening, ma'am.
Yes, ma'am.
Ma'am, I am Sudha. I am doing my research work in diabetic retinopathy using
Yes.
deep learning concept, ma'am.
Okay, ma'am.
Actually, I have dealt with identifying the lesions
Okay.
that were non-proliferative. So far,
Okay.
I have done my research for identifying the non-proliferative lesions alone, ma'am.
Okay.
So in my research work, I have used a Kaggle data set for prediction.
Okay. In Kaggle, what data set you used? What kind of data?
Kaggle, I have used a direct DB0 and DB1, ma'am.
Okay. With diabetics and without diabetics?
With yes, ma'am. With diabetics, ma'am.
Okay, okay.
So I've identified the lesions of hemorrhages, soft X-rays, hard X-rays, ma'am.
Okay.
So in my future work, I have planned to identify the neovascularization images, which comes under which comes under PDR.
Okay.
So can you suggest some standard database which can contain this neovascularization anomaly?
Okay, that we need, because both in Kaggle, UCI, and even more repositories are there, GitHub also. We need to figure it out. That you ask is available as a CSV or it is there as a JSON file. We need to find it out.
Okay, ma'am.
Okay.
So actually, I find it difficult to capture the to identify the neovascularization images, ma'am. I have contacted many hospitals,
Okay.
so I'm able to get only some 10 to 20 of images. I'm not able to get as a huge data set.
Okay, okay.
So that's why I asked this question.
Maybe you can contact me. Maybe I can do a research and tell you, because even in my company we train people.
Definitely, I'll contact you.
Yeah, then I'd be able to figure it out what kind of data sets that you need, and then we'll be able to help you on with that. Okay.
Thank you so much, ma'am.
Thank you.
Thank you, ma'am.
And GLWM is gray level weight matrix. Okay, so how are you going to use it? Is basically for what kind of application you're drawing, Hariharan, for GLWN?
No, ma'am. Actually, in my first of all, good evening, ma'am. Such a fruitful session, and I'm happy to be with you in this session.
Welcome.
So actually, in my post graduation, I did my project in by using machine learning and classification of child item in a gold tree. There, I have extracted the GLCM features.
Okay.
So I didn't have any issue in that GLCM. I know what is GLCM, ma'am. So I didn't know what is GLWM. And anyway, I'm not going to use it. Since in deep learning, the features will be extracted by the layer itself. So I want to know, I just want to know what is GLWM, ma'am. That's all.
It is for more, what to say, it is extracting, it's the next level with complete texture characteristics. With the texture characteristics. It is more with your texture characteristics. Okay.
Okay, ma'am. Okay. Thank you so much, ma'am. Thank you.
How can we customize CNN for denoising? There are different functionalities available. Paul sir, there are different functionalities available, and all are Python. All the packages that we are using in Python have got a source code. So we need to take with a source code and try to refine it and fine tune it and make an alteration in algorithm to enhance the features of it. Wherein which you'll be able to customize your CNN for denoising. Any other questions, please? And my website is www.cirf.co.in. Okay, and you can find my details. We are providing online internship for students now. Okay, there are two kinds of internship. Once the students, you are well trained in an application, we give you a project to work on after we go through an interview process. And for others, if you have, if you want to learn, we put into a process of training. Okay, we give into a process of training, and after the training session is over, you'll be doing a project, and once you're done, then live projects also will be given. Now we have opportunities for web application development too. In forensics, Anjali ma'am, you have asked a question, how image processing you used in forensics. Forensics is mostly, it's about detection, right? Forensics is mostly about detection. How do we detect? How do we detect objects? So maybe from an image or from a video, once it has to segment, extract the image, and then I have to go deep into with your images and find the patterns of it. If it is a murder, what is the pattern it has been done? If it is an image, what is that? Where the objects are placed before one time frame and the other time frame, and lot of researches are going on in forensics. Any other questions, please? I hope this session would have been useful. You can also subscribe to my YouTube channel. Okay, and like if you like my session, kindly comment on it so that when people see, they'll be able to know more about it. Okay, I'll just give my link of my channel, or I'll give the link of this video. Maybe I thought I will be doing it at the end of the session. Okay, they'll be able to know more about it. Okay, I'll just
Participants, any more clarifications?
give my link of my channel, or I'll give the link of this video. Maybe I thought I will be doing it at the end of the session. Okay, they'll be able to know more. Any other questions? So this is the link. I'm posting it on the chat sessions. So you can see the entire session video, and you can subscribe and give your comments. The feedback of the session, I would like to give it in the comment box so that it will be the best takeaway of my session. So I'd like to thank the management of Sona College of Technology. A special thanks goes to Gayatri ma'am and the department and all the organizers for having organized this event. Thank you all. God bless.
Thank you so much, ma'am.
Welcome, ma'am.
It was an excellent presentation. Excellent, really. From the bottom of the heart, I'm telling it's an excellent presentation.
Thank you.
I think most of our participants are the research scholars, faculty from various organizations, and the students, those who are involved in doing projects, research projects in real-time projects and image processing. So I hope this session would be very, very useful. And I would like to tell you at this juncture, I would like to tell you our project team, our students have won the first prize in the AICT Smart India Hackathon.
Congratulations.
Image processing background for the crop wheat detections,
Okay.
and that is using MATLAB and Python.
Okay.
And most of our students started doing the projects in machine learning.
Okay.
They have already learned Python, because along with MATLAB, they have started using Python, other software tools. So I hope this session would be very, very useful to all the faculty members, the research scholars, and the students those are doing a project in the area of image processing. I should really thank you so much, ma'am.
Welcome.
We all know very well what we achieve inwardly will change our outer reality.
Sure.
That credit goes to you. And the glow of one warm thought is worth more than money, people used to say.
Yes,
such warm thoughts and success belong to you, madam. Thank you so much.
Welcome.
So we thank sincerely Dr. D Doreen Robin for her wonderful presentation. I thank Professor Eldopal, my co-coordinator. Thank all the participants for making this session very, very interactive. So we have successfully completed our 4th day of the faculty development program on image pre-processing techniques. So we shall all meet tomorrow's session exactly by 5 p.m., the last day of our session. Thank you so much. Thank you, resource person, Dr. Doreen Robin, and all the participants. We shall all meet tomorrow. Thank you, ma'am.
Welcome, ma'am. I'm happy to hear that your students are doing projects in image processing and they won. My congratulations goes to the students winners, and there are a lot of students here and faculties here. Wishing you all the best on progressing yourself on image processing, on Python, on any research. And anytime you've got any doubts, feel free to contact me, my website address, and to my mail ID. Thank you all.
Sure, ma'am. Sure. Thank you. Thank you, ma'am. Thank you.